Welcome to Math 103. I'm Towell, and I will be talking today about section 2.3, and we're going to be talking about some mixture and some interest problems. I'm going to work my way through this worksheet, which if you wanted to, you can access that on Blackboard. Find that handout and work along with me. So let's get started. My number one problem is a mixture problem, we like to call them. And just reading through it here, number one, Bill, a chemist, he wants to mix 8 liters of a 40% acid solution with some 70% solution. And when he does that, he wants to get out of that a 50% solution mixture. The question is, how much 70% should he use to do that? Well, as in most word problems, what you want to do to set it up is either draw a picture, do a table, label, ultimately to get some type of equation out of the mix. In this case, I like to draw a picture. And the picture is just of the containers. What I'm doing is I'm adding 2 things together. So I'm going to draw one container here for the first part of that, and I'm going to add to it another container, so that's going to be my other part that I add. And when I add those two, well, that's going to equal up, combine the two together, my mixture. So we've got the 2 on the left adding together to get the mixture on the right. Well, which 2 am I adding together? Well, I'm adding here 40% and I'm adding 70%. So let's just note that here on those 2, 40% added to 70%. And then the mixture over here, well, we want the mixture coming out 50%, so we'll put our 50% on the right. All right, well, we also, along with that, on the lower part of those containers, we want to put amount. So amounts go with each of these percentages. Let's try to fill those in. We've got 8 liters, it says, of 40%, so I'm going to put the 8 liters there. Now, for 70%, how much do I have there? Well, I don't know. So I'm going to label that as my variable x, our unknown, which leaves my 50% amount. Got to fill that in. Well, let's think about that for just a second. If let's say I was adding 8 liters and the 70, I knew I had 3 liters. Well, in the mixture over here, what would I have? Well, I'd have 8 plus 3, 11 liters. If it was 8 and 10, well, I'd have 18 liters. So I'm adding the amounts to get the mixture amount. Well, in this case, I don't know that 70%, so I'm just going to say 8 plus x is the amount in the mixture. Now, once I have both of those things in each part, what I can do is set up the equation just like it is right here. I'm going to multiply the percentage times the amount in each case. So I'm going to take here the 40%. Of course, I've got to change it to a decimal. 40%, move it 2 places back. That would be 0.40. And then multiply it times its amount, 8. Well, that'll be plus then 70%, which in decimal would be 0.70, times the amount there is x. And then over here on the right, well, I've got 50%, so that's 0.50 times 8 plus x. And that sets up a nice equation, an equation that I can solve for x. And what I'm doing basically here is I'm adding the amount of acid in both cases, and that'll be the amount of acid in the mixture. That's the way it works. All right, so now we just work this problem out. We can multiply 0.40 times 8. Do that. You get 3.2. 0.70 times x. 0.70x is all we can really write there. Then over here on the right side, well, we got 0.50 and in parentheses 8 plus x, so I've got to do a little distributing, don't I? Multiply that 0.50 times 8. Well, 0.50 times 8 is 4. And then 0.50 times x is 0.50x. All right. Now we just solve this linear equation. Get the x's on one side, the constants on the other. I'm going to go ahead and over here subtract my 0.50x from both sides. And then subtract 3.2 to get it to the other side. I'll go ahead and do that right there at this time too. And so on the left, I've got 3.2 minus 3.2. Hey, that's 0. 0.70x minus 0.50x, that's 0.20x. Over here on the right, I've got 4 minus 3.2, that's 0.8. 50 minus 0.50 minus 0.50, hey, that's 0. So it's just 0.8 on the left. All right, so it's 0.20x equals 0.8. All I have to do then, divide off 0.20. That'll get me x by itself over here on the left. 0.8 divided by 0.20, that's 4. All right, so we've got our equation solved. Now we just have to ask ourselves, is that the answer that we want? X is 4. Well, x is the 70% amount. Hey, that is what I'm seeking here. So the answer is the 4. Now, what units is that? We're talking liters here, aren't we? Liters. 4 liters. All right, so 4 liters is what Bill would need in that case. Let's go on here to problem 2. Later that day, it says, Bill needs a 25% solution. How much pure acid would he need to mix with 4 liters of 5% solution to obtain the desired concentration? All right, so again, we're adding 2 quantities together. So let's make our 2 containers. And adding those 2, and then over here on the right, we'll draw the mixture container a little bit bigger because we're adding those 2 together. All right, now the question becomes, which 2 are we adding together? And you don't want to just jump the gun and start writing 25, 5, because it may not be in that order. Which 2 are we adding together? We're actually adding the pure acid with the 5%. So on this side, we're going to put the pure amount, pure solution here, and then over on for the second part, yeah, that's going to be the 5%. And then the mixture is going to come in at 25%. That's what we want. Now, pure acid, we're talking, we need to talk percentages there. Well, 25% solution or 5% solution means 5% of the mixture is the acid or whatever, alcohol or whatever we're talking percentages of. So pure acid would be what percent? Well, if it's pure, it's all acid, 100%. So 100% is our percentage for the pure here. All right, what else do we need? We need the amounts in each case. How much pure acid do I have? Well, I don't know. That's our unknown. Call it X. 5%, well, I got 4 liters of it. And then 25%, I don't know how much will be in the mixture. However, I do know I have X liters here, 4 liters here, so that's X plus 4 liters of 25%. Now, as in the first problem there, we multiply each percent times the amount, of course changing the percents over to decimal. 100%, move it 2 places, you got 0.100x. Then I multiply the percentage times the amount here. 5%, move it 2 places back. Well, that's going to put it 0.05 times the amount would be 4. And then the mixture here, 25%, 0.25 times its amount would be x plus 4. There we go. There's our equation to solve. Let's go about solving. All right, so 1.0x. May not need to write the 1.00, but let's leave it in there for right now, and I'll show you why in just a second. Now 0.05 times 4, multiply those together. Hey, that's 0.2. Over here on the right, well, we got to distribute our 0.25, multiply it by both, so we get 0.25x. 0.25 times 4, that nicely works out to be 1. All right. Now I get the x's on one side, constants on the other, so I'm going to subtract my 0.25x from both sides, and that's why I left it 1.00. Those line up nicely. And I'm going to subtract 0.2. Here's what I wind up with. 1.00 minus 0.25, that's 0.75x. .25 minus 0.25, 1 minus 0.2 is 0.8. All right, so all we have to do is divide by 0.75. And what we get is x equals 0.8 divided by 0.75. Now, what we need to discuss on that maybe is a little bit of simplifying. Yeah, we could divide that and get a decimal. It doesn't work out to be a nice decimal. It's a repeating thing. So here's what we can do with that. To get rid of these decimals, what I can do is multiply. Since I've got two places on the bottom, let's multiply top and bottom by 100. Well, we do that, what we wind up with is 0.8 times 100 is 80, and then 0.75 times 100 is 75. And that gives us a nice fraction we can reduce. 80 divided by 75 reduces by 5s. 80 reduced by 5 is 16. 75 divided by 5 is 15. So we wind up with 16/15, and that is 16/15 again in liters. All right, so that's our couple of examples of a solutions problem. Let's move to